Introduction.
Mother, what are you doing?
I'm stitching a pattern on your frock.
Can you stitch similar patterns on some more frocks of mine, Mother?
Why not? But I do not have enough buttons for those patterns. Will you buy them for me, Vanshika?
Definitely, Mother. How many would you need?
I will need 16 for one pattern.
I want patterns on 5 frocks, so I will buy 16 times 5, that is 80 buttons.
In this lesson, you will learn algebra. Objectives. At the end of this lesson, you will be able to define algebra, define variable, use variables to express common arithmetic properties, use variables to express geometric concepts, translate real-life problems into algebraic expressions, find the concept of variable. Ananya creates dancing figures using triangles made of wood. One day she receives a request from her friend Rita for 10 such dancing figures. How many triangles will Ananya require to create them? Take a careful look at the dancing figure. Ananya uses 9 triangles to create it. Therefore, in 10 dancing figures, Ananya will use 9 into 10 is equal to 90 triangles. Rita's aunt notices the dancing figures and likes them so much that she orders 50 such pieces. How many triangles will Ananya use in these 50 dancing figures? Ananya uses 9 triangles in one figure. Therefore, in 50 figures, Ananya will use 9 into 50 is equal to 450. Ananya will use 450 triangles in 50 dancing figures. The triangles Ananya uses in a single dancing figure are fixed. However, the total number of triangles used by her varies, depending upon the number of dancing figures she makes. We can, therefore, generalize by saying algebra. Algebra is a division of mathematics which represents numbers with letters of the alphabet. The letters are replaced by different numbers to obtain different answers. Therefore, as the letters assume varying numeric values, they are called variables. Let us look at some more real-life situations in which algebra is used. Raju cleans cars in a housing society. For every car he cleans, he charges 200 rupees. Express Raju's total earnings in terms of a variable. Raju's total earnings depend on the number of cars he cleans. Suppose he cleans n cars. Raju's cleaning charges for one car is 200 rupees. Raju's cleaning charges for n cars is equal to 200 into n. Therefore, Raju's total earnings are 200 n rupees. Riya is 5 years old now. Express her age 10 years from now. Generalize the expression with a variable. Riya's present age is 5. Riya's age after 10 years is 5 plus 10. Riya's age m years, hence 5 plus m. Arithmetic properties and variables. Let us now express some commonly used arithmetic properties with the help of variables. These properties are commutative property, associative property, the commutative property. Addition and multiplication of two numbers are commutative. In other words, a change in the order of the two numbers added or multiplied does not affect their sum or product. 9 plus 8 is the same as 8 plus 9. 5 into 6 is the same as 6 into 5. The commutative property holds true for all numbers. We can therefore generalize it with variables as a plus b is equal to b plus a. A into B is equal to B into A. Associative property. Addition and multiplication of three numbers are associative. In other words, a change in the order of the three numbers added or multiplied does not affect their sum or product. 9 plus 8 in brackets plus 7 is the same as 9 plus 8 plus 7 in brackets. 5 into 6 in brackets into 4 is the same as 5 into 6 into 4 in brackets. Associative property holds true for all numbers. We can therefore generalize it with variables as bracket starts A plus B bracket closes plus C is equal to A plus bracket starts B plus C bracket closes. Bracket starts A into B bracket closes into C is equal to A into bracket start distributive property. Look at this expression. 5 into bracket starts 8 plus 9 bracket closes. It can also be written as 5 into 8 plus 5 into 9. This property is known as distributivity of multiplication over addition. It holds true for all numbers. We can therefore generalize it with variables as bracket starts A plus B bracket closes into C is equal to A into C plus B into C. Geometric concepts and variables. The concept of variables can be extended to geometry. For example, diameter of a circle is twice its radius. It can be expressed as diameter is equal to 2 into radius or d is equal to 2 into r, where both d and r are variables. As r changes, d also changes. Let us use variables to express perimeters and areas. Perimeters. Perimeter of any two-dimensional figure is the length of its boundary. Perimeter of rectangle ABCD is equal to AB plus CB plus DC plus DA. Opposite sides of a rectangle are equal. Therefore, DC is equal to AB is equal to L for length. DA is equal to CB is equal to B for breadth. If perimeter is represented by the variable P, then P is equal to L plus B plus L plus B is equal to 2L plus 2B is equal to 2 bracket starts L plus B bracket closes. Variable P varies with variations in the variables L and B. Perimeter of square. ABCD is equal to AB plus CB plus DC plus DA. All the sides of a square are equal. AB is equal to CB is equal to DC is equal to DA is equal to S for side. If perimeter is represented by the variable P, then P is equal to S plus S plus S plus S is equal to 4S. Variable P varies with variations in the variable S. Areas. Area of rectangle ABCD is equal to length into breadth. If area is represented by variable A, length by L and breadth by B, then A is equal to L into B. Variable A varies with variations in the variable L and B. Area of square ABCD is equal to side into side. If area is represented by variable A and side by S, then A is equal to S into S